you know whether that aerial mapping program can look at heat loss through the walls, but only through the roof? Because if it only does the roof, I don't know if it's all that useful. A typical residence loses more heat through the walls than through the roof. If it doesn't, it's easy to fix by blowing insulation into the attic. So if it makes homeowners think that they can turn their house blue on the map by blowing insulation into the attic and forget about the rest, it may be doing a disservice.
Yeah, there's some subtlety involved. Your concerns are accurate. That's the difference in the accuracy of that sort of service versus Energuide. Energuide also looks at mechanical systems and everything else. There's no question there's differences there, but it's a conversation starter. The go-to response if somebody basically gets in touch and says, you know what, I think my building's better than that. Or if somebody is looking to buy a home and they say, you know what, I think he's trying to game the system, then we can just ask them to share their energy bills. If you guys have heard of the green button programs out east, basically online, you can tell your utility provider that I'm willing to share my consumption data with anyone, basically. And as that movement kind of comes west, it becomes very easy to collect the energy data, or the energy consumption data from utility providers, and then calibrate the model to what's going on. So if you've got the energy consumption, you can't game it through just insulation on the roof.
Excellent. Thank you, Stu. One question there. Go ahead.
What about inaccuracies that are inherent? Some homeowners keep temperature at low levels, some keep them at high levels. So the same house with the same insulation could give you quite a different picture. People gone on holidays. The legal aspects of it, if somebody in the public bases a buying decision on a picture that might be wrong, I think are tremendous. So I really don't see that as a viable alternative for those reasons.
Again, it's a conversation starter, right? If you look at the map, you start having these concerns, we're doing the right thing. The first thing we do when somebody calls up and says, you know what, I think this is wrong, we say, here's a certified energy auditor. Please have them come into your home if you'd like to have a better assessment and give us the Energuide rate or provide us your energy bills. If the person is having a bluer roof because the temperature set point is lower, well, great, they're using less energy.
It's simply a tool.
Yeah, it's a conversation tool. It's in your face. It's shaming. It's all sorts of things.
Maybe your neighbors.
However, this could become a legal issue in the selling of houses,
Yeah, it's a fantastic.
where a particular vendor will lose a sale because the inaccuracy that was being portrayed, and the decision that's so based on it.
The legal side of this basically falls under the public domain. These are photographs, infrared photographs, but it's no different than Google Street View or anything else.
What about sharing that? It becomes a potential question.
And it's a great thing to put in the parking lot to talk about
Yeah, exactly.
after the discussion. Perfect. So we'll take another question. Go ahead.
I think what you said was great, and I think I agree with a few of the comments out there, but it's a great conversation starter. If it's happening, that's awesome for Edmonton. I have a question that's city related. The city is going to be heavily invested in the new arena happening next door to us. I know you've only been in the city for 4 months, but do you know if there's anything tied to the building of that arena, and if we're going to make sure that it is going to have sustainability, like if there are going to be green aspects, or if our putting criteria is up so that if it's going to represent Edmonton, it should represent the green building plan?
Yeah. So just to repeat the question for those that couldn't hear it, for the new arena that's being built, are there green programming or green aspects to the design that are being implemented and then going to be talked about? Yeah.
Yes and no. Sorry?
Turn the mic on.
Is it not on? It's on. Hold it closer. Okay. I'm not involved in that. I've had some conversations with people that are. The answer is yes and no. You'll probably be disappointed, but yes. And I may not have my job long enough.
So I'm going to take 2 more questions and we'll move on to Dave. So I have one fellow in the back, and then I would like a lady question as the last one. Kate, so in the back, go ahead.
Did the city shoot down requiring an Energuide rating on new permits at all? Like some municipalities on the coast require 86 Energuide rating on your submitted plans, and then the homeowner is responsible for having it meet that at the final inspection. And all the costs are borne by the homeowner, but it's part of the plan process. When you submit plans, it has to have an EnerGuide rating, and it has to be checked basically with final inspection.
Yeah, that's exactly what we're shot down.
It's-
Basically,
it's said-
the two sides of that, you're talking on the coast. So the Vancouver area has,
Yeah.
they have a charter city status,
Yeah.
which grants them the ability to define energy efficiency that is independent from the provincial jurisdiction. The Alberta Municipal Government Act does not give jurisdiction to cities, municipalities, to enforce any sort of building safety code that is beyond what the building code says. So we can't say all buildings in Edmonton must be minimum EnerGuide 86. We would get sued. We cannot do it.
Even on new ones? Because on,
Yeah, doesn't matter.
St. Status on the coast, any new permit has to have EnerGuide rating 8.
We theoretically, legally could require
Yeah.
a rating, but that's where there's no appetite. That's the roadblock I ran into. Basically, they're not willing to have that fight.
Okay.
Excellent, great question, thank you. And Kara?
In 2006, we had our home ATCO Energy audited, and he took a walk through the house and then gave us some verbal comments. About a month and a half later, we got the written report, and the written report had nothing in it about the uniqueness of our house. So I called him and I said, "What's going on?" And he said, "Well, you have to understand how many of these we're doing, and if we individualized each report, we'd never get them done." And I said, "You're kidding me, right?" And so I told him about a couple of the things about our home that were unique that were not mentioned in the report. So he mailed out another report 3 weeks later where he just pulled out words and put the word I mentioned in. So I got about 4 points higher. But have you heard of that before? And it completely destroyed my faith in the EnerGuide program.
You said that was an EnerGuide process, or?
It was at the ATCO EnerGuide, can you get the sticker that does a rating on your house?
But that's not the EnerGuide.
Well, it's,
Yeah, the criticism there would be from the provider of that audit. There are many different certified, I'm going to use the wrong terms, I'm sure, but there are many different people that provide EnerGuide rating and energy audits.
okay.
So there are certainly things you can do to criticize the EnerGuide program, but I don't think that is the fault of the program. That would be, I would talk to the person who provided it. But
So-
again, it's something to think about again. So if you look at how much you paid and what you got for it,
It was the government-sponsored ATCO EnerGuide one. And we didn't pay anything. It was, we got it at the Reno show. Mike Holmes was recommending it. So how does a consumer protect themselves against that? You have a list of people.
If we knew that answer, we would be gazillionaires.
Oh.
I would love to talk to you actually after this presentation and capture that story.
Okay.
Because it's important for all of us as people that have gone through these programs, not just to talk about how great they are, but also to share the things that we saw as roadblocks and deterrence programs. So I really appreciate your question. Thank you.
I think that that's, again, one of the benefits of investing in this sort of online portal is because you could go there and just rant your mouth off if you wanted to, right? Right now that doesn't exist.
Excellent. Thank you. Those were great questions. Store up any more that you have for the end. Write them down, capture them somewhere, because we might have time to take a few more. So I have the pleasure now to introduce Dave Turnbull. He's the Product Development Manager for the Landmark Group of Builders since 2007. Dave has been leading the charge towards net zero for the group, with Landmark's stated goal of net zero by the end of 2015 at no extra cost. The next 2 years should be interesting. Dave is a 30-year veteran of the home building industry, working as a tradesperson in manufacturing, distribution, and as the supplier to Edmonton's builders. Dave is currently the chair of the Built Green Canada Board of Directors and has had the privilege of working with the City of Edmonton on many of their green initiatives. Please help me in welcoming Dave to the stage.
There we are. Thank you. Sorry, I just hate podiums. I kind of like to wander about if that's all right. Mercifully, I have probably the shortest presentation tonight, which is a good thing. Yes, and the crowd was incredibly mild. When we were putting this thing together, one of the things we wanted to talk about was the advent of heat pumps into net zero energy design. And one of the questions that Peter posed is, are they really a game changer? And it's not something I definitely considered, but let's have a look at it, shall we? When we're talking heat pumps, I'm hoping most of you are fairly well versed. For those of you who are not, we're just going to go through some basics, and I'm going to apologize if I'm oversimplifying. We have ground source heat pumps. This is something where we actually use the ground as the source or the sink for the energy. We also have air source heat pumps, which is what personally I'm more familiar with. This is what we've used on our net zero projects, and we've had some good success with. This is actually using the air, the heat that's actually in the air, through a heat pump system to heat your home. And we'll talk about the differences here. A heat pump, basically, it's a great little technology, probably one of the most energy efficient technologies for moving heat around. So if we're looking over here, we have external air. This could also be the source of your heat from the ground. You have a refrigerant in this closed loop here, and this refrigerant is actually a gas at a low temperature. So what it does is, as we blow the air across here, this actually gasifies, and it goes into a compressor. And that compressor, once it's gasified, the compressor actually takes the heat that's in there and makes it hotter. As the pressure builds, the temperature goes up, the volume goes down. It takes me back to, I'm thinking, grade 10 science, that old PVT thing. I had to revisit it when I was thinking about this. So what we have now is we have a higher temperature fluid running through here. Again, this is to a hot water exchange. What we do in our product is actually an air exchange, so we have a fan running through this. Once it cools down, again, we're going through an expansion valve where the pressure is reduced. So as you reduce the pressure, you cool the refrigerant, and it goes back as a liquid, and it starts to cycle all over again. It's a fairly simple thing. It hasn't, as a technology, I think the first one was late 1700s. So it's not exactly the newest technology on the market, but it's definitely got a little bit of a track record to it. So the system that I'm most familiar with, and what I'll use as my reference for an air source heat pump, is a relatively new product on the market. It's from Mitsubishi. It's called the Zuba Central System. So I think Peter's going to talk a little bit about mini splits. Yes? Okay. This is actually just a central system. So for the homeowner, this is something they're very familiar with. And that was part of what was attractive to us as a builder in not putting something into the home that was going to be a little bit different. Landmark is a company, for those of you who don't know us, we're a small builder. We build about 1,000 homes a year. So when we do this, we don't have the benefit of having a custom rapport, I guess, with the homeowner. We're actually trying to sell things to the general public. So we want to have things that are very familiar to it. So we opted to go with this system. The nice thing about this is a cold climate air source heat pump. It actually has COP, and Stuart was describing that. The COP is over 1 at minus 35 degrees Celsius. So that's actually quite important, because as we get into some of the other technologies that are out there, and there's a number of them. These guys are all manufacturers of air source heat pumps. They're all going into the cold climate version, especially Daikin, the Alta Therma. That one's getting pretty close. Fujitsu's got some new stuff coming out in the next little while. And there's a company out of Ontario called Ecologics that actually has $2 million in federal funding to joint venture with, I believe it's Emerson Technologies, to develop a cold climate air source heat pump system, which oddly enough is, I think it's coming up this summer is when they're set to launch it. The current products that are out there, they have a COP over 1 to minus 15 to minus 20, which still isn't all that bad, but the minus 30 gets you down into our neck of the woods a little bit faster. So that's kind of the basics of it. If we're looking at the effects of a heat pump, so what I'm going to do is I'm just going to walk you through one of the homes that we just actually, the homeowners take occupancy here in about 2 or 3 weeks. So this is our Madrid. The actual home is actually, it's a reverse plan of this. So it's like I said, it's a reverse view. It's roughly 2,400, 2,386 square feet. Now this has 2x8 framing, and I think Peter's going to talk a little bit about what he does for building envelope. But Landmark is a little bit of a different company in the sense that we actually manufacture the walls and the components off-site. And we take them to the site and they're erected on site with a crane. So we don't have, unfortunately, we don't have the opportunity to build some of the other staggered wall systems and things like that that are out there. So we have to keep to a very basic kind of framing system. So 2x8 framing with this is 24 inch on center. It has 5 inches of 2-pound spray foam into it, and 2.5 inches or 2.25 inches of John Mansville Spider, which is a blown-in fiberglass product. It has R80 in the ceiling. It's R20 foam. We spray R20 foam into it and put R60 blown in over top of it. And what did I do there? R16 under the slab, which is pretty much stock and trade for this kind of a product. The basement is R20 spray foam onto the concrete with R14 voxel in front of it in between a 2x4 wall at 24 inches on center. So it's, on the conservation side of it, we've sort of gone along the way that Stuart likes. We're not to the extent that many other net zero home builders are. The windows are sited for orientation. We use a low iron glass, triple glazed window on the south exposures. We use high R value solar, with a low solar heat gain on the west, just so that we don't have higher cooling loads. Now, I don't know if I mentioned, but this particular home faces east. So we've kind of gone away from the normal operating of a net zero builder, and we've gone to an east orientation, which most builders, that's what we're building with. We don't always have the opportunity to build facing south. The annual heating load for this, or annual heat consumption for this, if we were just to go straight electric, 100% efficient, would be 10,296 kilowatts per year. Not exactly the amount of solar you want to put up there if you expect to cover everything off, including the occupancy use. So with a cold climate air source heat pump, it actually brings it down to 5,500, which is a much more manageable system. Now, if we were to go to a ground source heat pump, and I'm being a little generous here with a COP of 4, that would bring us down to 3,900 kilowatts. So it's not an exorbitantly huge difference between the two, and you kind of have to work out the economics of that. So let's talk about that. Based on the same square footage of the home, a typical furnace system in a home, depending on what all you're throwing into it, will run you, as a builder, somewhere around the 8,000. You can probably run it as high as 10,000 if it's a bigger home, depending on the accessories you're looking for and depending on the brand you're going after. The cold climate air source heat pump added, will add anywhere from $65,000 to $8,000 to the project. In our example, the cost on this particular house was $7,000 more. So if we look at that, we divide it by the 4,790 kilowatt hours, we work out to $1.46 per kilowatt hour saving. It's still well below the cost of PV, so it's definitely something worth doing. In the same, it would also reduce the panels we needed on this home by 13, which is always a concern. Net zero is becoming a three-dimensional calculation. It's cost of generation, cost of conservation versus how much room you actually have on the roof. And the ground source heat pump would have saved us the 63.69, so again, you're about 251. So it costs a little bit more, but it also has a little bit longer life to it, so there might be a life cycle conversation going on there. And it reduces the number of panels we need by 17. The benefits, these things give, I see I've only got 5 seconds, I'm going to take longer, sorry. They also give air conditioning as well, so the cost difference isn't as large as we think. One of the things that we're finding is, as a new home builder now, is that air conditioning is one of the most up-and-coming upgrades that we are providing our consumers now. So when you consider that as probably on this house, probably a $3,500 touch, it actually brings these things a little bit more into line. We reduced the number of panels we needed on the home. Again, on the net zero home that Madrid that I was showing you, if we didn't have that cold climate air source heat pump, there is no way that this was going to be a net zero home. We just could not get a good enough panel and enough of them up onto that roof. And it's a big roof. May allow us to use a lower efficiency panel and save money that way. On that Madrid, it's actually, in terms of design, it's one of our worst designs as far as performance goes, but it is what the customer wanted. But what it might do is it might allow us to go, when we had to use a SunPower 325 watt panel, which is horribly expensive. But you know, if we could, on a normal home, we might have been able to reduce that down to something less expensive and save some money there. And this allowed us to use a less robust wall system, which again fits into our plan. Unfortunately, like I said, we can't build 12-inch thick walls. It just doesn't transport on a truck very well. Shortcomings for cold climate air source heat pump, first cost, I mean, they're $7,000. Customer acceptance, they have a hard time understanding what it is when you're talking to them about it. I basically explain it as an air conditioner that runs backwards. Usually that's about as far as I have to go, though. It's, you know, it's sometimes the simplest, Mom, Daddy, where do babies come from? The hospital. Qualified installers, it's a newer technology. A lot of the current trades don't understand it. There are a couple of guys in town here that do, and they're fantastic. Sizing is a problem. Currently, there's only, in this particular model, a 36,000 BTU unit available. So if you're using something around that, you're fine. But we have a 14-unit townhome complex that we did for net zero, and there was no way. I'm getting that has a 4.5 kilowatt heat loss on it. There's just no way that I could afford to put one of these things on. I wasn't going to save that much money. For ground source, again, first cost, qualified infrastructure, design and execution on both sides of it. You want to make sure that your designer knows what they're doing. You want to make sure that your installer knows what they're doing. Neither product, and I want to make this abundantly clear for those of you that are new, neither one of these products should be used unless augmented by solar. And here's why. Cost of gas. We live in a province where the gas is $3.99 a gigajoule, give or take. Cost of electricity, roughly 10 cents by the time you work out transmission charges, which works out to $27.80 a gigajoule. So, unless you have a COP of 7 or more in your system, your customer is going to pay higher bills while using less energy. And they are going to hate you. As a home builder, I know what that feels like. We have spent many years with customers hating us. We don't need another reason to do that. So just a word of caution. This situation is very unique for Alberta. We have low gas and high electricity. In areas where there's hydro, if you go 2 provinces over to Manitoba where gas is twice the price and electricity is half the price it is here, hey, these things actually make a lot more sense just in a day-to-day application. But right now in Alberta, these things don't make sense unless you're augmenting them with solar. So the question is, are they a game changer? All I could determine, and this is the same thing that I get with any kind of sustainable building, I once asked, you know, is there any black and whites in sustainability? And the answer I got was, it depends. With that, I thank you for your kind attention and invite any questions. I'm 4 minutes over. Yes, sir.
What's the size of these units like?
Their physical size? The outside unit is about this tall. about that wide, give or take. It's a little bit, it's tall and thin as opposed to an air conditioning unit, which is a little square, which makes that whole explanation I was giving to the customer a little harder. It doesn't look like an air conditioning unit. We have one back there. Yes?
What's the refrigerant?
The refrigerant in this one is an R410A.
Which is CFC free?
Yep.
HCFC.
Yep.
How is it for noise?
Actually, this section is really cool. When it's running full out, go 54 decibels.
That's quiet.
That's a pretty
That
quiet
is
little
quieter
unit.
than the neighbor's dog.
Yeah. But, according to some of the new bylaws from the city, we still have to put that in the backyard.
We've got a question from up there. Yeah, go ahead.
Familiar with, older style heat pumps where they're great in moderate temperatures, not extreme cold weather winters, and
Yep.
they are used, when they're cooler evenings, and then when it gets cold enough, then the main furnace kicks in to supplement. With yours, if I can just try and figure out, we're talking about a heat pump that will run at minus 25 degrees.
This is our main source of heat.
Well, then why do we still need the furnace? I mean, I see.
Well, it's an air handling unit is what it is.
Okay.
So what you've got is you've got the exterior compressor unit. Inside is an air handling unit.
It's just the HVAC.
Just the HVAC side. Now, attached to that, we also, because we do get below minus 30 and stuff like that, with air source heat pumps, as the temperature gets down, the BTUs that these things put out lower as well. So this thing puts out 36,000 BTUs down to, and this is in Fahrenheit, I didn't have the time to calculate it out, but it's about 5 degrees Fahrenheit, which I think is about minus 15, 16, somewhere in there. That thing puts out 36,000. At minus 35, it's putting out about 27,000. The design loss on that particular house is 32,000 BTUs at minus 34. So we do have a small electrical resistance in here there to back that up.
Excellent. Before we move on, Stu just had a comment.
Just on your question, the nice thing about the Zuba is it actually comes with integrated backup heat in it. That's the major difference between the two systems that you guys will hear from. There's two system options in the Zuba. There's either an electric integrated element or there's a hydronic coil that you can connect to your domestic hot water. So you don't have to worry about redundant systems. You can put the system in. You can actually go up to 30 kilowatt electric element in it. So you could put this thing in a huge house. It's just how much of the demand will be actually coming from the air source heat pump and how much will be pure electric. So there's an efficiency loss if you go above what David's saying.
And if you build one of his passive houses, you can probably build that huge house and never use that 30 kilowatt heat.
Two more questions. We'll take this one on this side and then one.
I'm always worried about the constant need for electricity on the pump side when you're off grid. Is it practical for off grid?
I don't know that I'd go venturing into that. It's an awful lot of draw. When you're trying to pump out, especially as it gets colder, you have a huge draw on that sucker and producing very little heat. I don't think I'd venture.
The same question, the question is, when you're talking solar array, that's grid.
Solar array, yeah, ideally, I'm a big fan of grid tie. I think in the future there's going to be some real advantages to it versus standalone.
Excellent. Did I miss any questions over here? We do have, no? Okay. So if anybody has any more questions, again, save them to the end because we might end up with some more time. Dave, you can just